Hi! Welcome back. Today's lesson is 1.3, Properties of Numbers. And there's a lot of writing today, so I just want to encourage you right now to go ahead and pause me and write down all of these properties. These are all the properties of equality. We have the reflexive property, which basically says that any quantity is equal to itself. Then we have what that looks like in a symbol form. And then some examples, things like 5 equals 5, 4 plus 7 equals 4 plus 7, anything equals itself. Then we have the symmetric property, which says that if one quantity equals a second quantity, then the second quantity equals the first. So it's kind of like looking in a mirror and what you see is, your reflection. So it's kind of like if A equals B, then B equals A. And so in this case, I have an example here. If 8 equals 2 plus 6, then obviously 2 plus 6 would equal 8. The transitive property is one of our favorites. If one quantity equals a second quantity, and then that in turn equals a third quantity, then the first quantity equals a third. And again, that sounds very wordy. It's a lot easier to just kind of look at the symbol here. If A equals B and B equals C, then A equals C. Basically, it gets rid of the middleman. So, we have A goes to B, B goes to C. So we can kind of get rid of the B, and we can just simplify that and say A goes to C. So here we have an example of 6 plus 9 equals 3 plus 12, and in turn 3 plus 12 equals 15. We can get rid of the 3 plus 12 part and just say 6 plus 9 equals 15. That's a transitive property. And then we have the substitution property, which basically says that a quantity may be substituted for its equal in any expression. So if A equals B, then I can replace A with B in any expression I want. So an example here is if n equals 11, then in the expression for n, I can replace the n with an 11 and get 4 times 11. So those are your properties of equality. You want to write them down in your notes. And then we have some addition properties, and these are pretty important. First off, we have the additive identity, which says for any number A, the sum of A and 0 is A. So basically, 0 is what we consider, oops, that's not what I wanted. Let's undo that. Hold on, sorry. There we go. So we want to kind of box the 0 there. So 0 is what we consider the additive identity. Basically, you can add 0 to any number and it stays the same, which we can see here, A plus 0 or 0 plus A is A. An example, 2 plus 0 is 2, 0 plus 2 is still 2. And then we have the additive inverse, which basically says a number and its opposite are additive inverses of each other. Basically, they undo each other. So if we have a number A, the opposite of A would be negative A, and when you put those two together with addition or subtraction, you get 0, which again was the additive identity. It's really important for you to understand the relationship between identity and inverse. Inverses always produce the identity. When you put two inverses together, they will produce the identity for that specific operation. So we also have some multiplication properties, very similar ones. We want to kind of get this guy out of the way here. Let's see. Well, there we go. I'm not sure that that's, let's just close that for the time being. So here are your multiplication properties. We have, like before, we had the additive identity. We also have a multiplicative identity, and that basically means that it's a number that if you multiply any number by 1, it's also itself. So for any number A, the product of A and 1 is itself A. So A times 1 is A, 1 times A is 1, 14 times 1 is 14, 1 times 14 is 14. So basically, any number times itself, any number times 1 is itself. And then we have the multiplicative property of 0, and you all know that one probably from middle school or elementary school. Basically, the product of any number and 0 is 0. 0 times anything is 0, so we have our examples there. And then like before, with the identity, we have the inverse. So the inverse for a number, A over B, now don't let the fractions scare you. You can have a number as simple as 5, and you can write it as 5 over 1. So, but because we reciprocate in the case of inverses, we use fractions. So for any number a over b, where a and b are not 0, then there's exactly one number b over a, so you can see what I was talking about. Here you have a over b, and again, we fall into that highlighter. I'm not exactly sure why that highlighter is showing up there, but let's undo it and go back to the, so here you have this number, a over b, and the inverse is b over a, so you basically flip it over. So again, if you have a number as simple as 5, the inverse would be 1/5. You would flip it over because we would just write 5 over 1, and we'd flip that over to 1 over 5. So that's the opposite. Basically, the opposite of multiplying is dividing. So if we have a 5, 1 divided by 5 is the inverse of 5. So the point is that when you multiply the two numbers, when they're inverses again, you get 1, the identity, which was up here. So we have 1 is our identity for multiplication and division. So again, I want to reemphasize, inverses will always produce identities. When you have two inverses and you multiply them together, they will produce the multiplicative identity. When you have inverses and you're adding them or subtracting them to each other, then you're going to produce 0, which is the additive identity. So make sure you write that down. And now we go to the more fun part, which is our examples. Let's get this guy out of the way. And so here we go. Evaluate 7 times the quantity 4 minus 3 minus 1 plus 5 times 1/5. And not only do they want me to evaluate this, which is not the hard part. The hard part is generally the second part where it says name the property that's being used. That's where students sometimes have a little bit more problems with this guy. So let's make sure that we have the right thing here. Okay, so the first thing we're going to want to do is parentheses first. So we're going to go 7 times 4 minus 3 is 1 minus 1 plus 5 times 1/5. But next to that, we have to write down what we just did. So we know that 4 minus 3 equals 1, which is why we put a 1 here. But basically what we did is we replaced the 4 minus 3 with the 1. So that is the substitution property of equality. Because if 4 minus 3 equals 1, we're replacing the 4 minus 3 with the 1. So that's the substitution property. Our next thing to do is any exponents, but there aren't any exponents. And so then the next thing would be multiplication or division from left to right. So we're going to start over here, 7 times 1, and we have 5 times 1/5. Those are both multiplication, but we want to go from left to right. So that means we're going to go 7 times 1 first, and we're going to get 7 minus 1 plus 5 times 1/5. Okay, and then the reason or the step for that is we have a number times 1, and if you recall from earlier, 1 is the multiplicative identity, which says that if you multiply any number by 1, you get the number back. Multiplicative identity. So that is our property for the second step. All right, and then we have our next thing to do, which would be to do the 5 times 1/5, because that's the other part of the multiplication there. So 7 minus 1 plus 1, because 5 times 1/5 is 1. So whenever you have two inverses, they produce the identity. So in this step, we're going to put multiplicative inverse. We multiplied the two inverses and got the identity. And I said earlier that inverses always produce the identity. Alrighty? So now after all that, we do addition and subtraction, again, in order from left to right. So we're going to start right here. 7 minus 1 is 6. And that is just subtraction. subtraction there. And then our final step is to take the 6 and the 1 and get 7, and that is simply addition. So not only do we need to do our steps, that was probably the easy part, but we also need to make sure that we're writing down the reasons or the properties that we're using for each step. So now you will attempt this do-it-yourself question. There's a part A and B. The good news is that I've already filled in the steps, so we know the answer is 6, and in B we know the answer is 1. But what I need you to do is for each step, starting right here with the equal signs, we need to provide a reason or a property that's used for each step. So you'll need 4 answers here, and you'll need 1, 2, 3, 4, 5 answers for part B. All right, so now we're going to add some more properties. I don't know if I can get this kind of out of the way here. That'll probably work. So we have the commutative property and the associative property. And commutative property is all about order. It basically states that the order in which you add or multiply doesn't affect the sum or product. You can add or multiply in whichever order. So basically, A plus B is the same thing as B plus A times B is the same thing as B times A. And we have some examples over here. Associative property is more about grouping. So with associative property, you're talking about parentheses and that kind of thing, and how you group things together. But again, the property states that the way that you group 3 or more numbers when you're adding or multiplying doesn't affect the sum or product, okay? So this one was a little bit longer, so I kind of had to squeeze it in over here. So we know that if you're adding 3 separate numbers, you can group A and B together and then add C, or you can group B and C together and then add A. Same thing for multiplication. And then as an example, I didn't have space up here, so the examples are down here. You can kind of ignore the bar there, and those are the examples. So we are now going to do some examples with these little guys, and then we'll be done. So in this example, they want us to evaluate, and again, like before, we're going to evaluate, but we're also going to name the property that's used in each step. So I'm going to go ahead and rewrite this over here. And remember that it doesn't matter which order we multiply in. So what I'm going to do is I'm just going to make it easier. I'm going to take the 5 times the 2. And then I'm going to take the 7 times the 4. Now, we don't have to do it this way, but if I do it this way, to me it's just easier to multiply 5 times 2 than it is to multiply 5 times 7. So what I did there is I changed the order around. But since the order doesn't affect what my final answer will be, this is the commutative property of multiplication, and you can abbreviate it like that. After a while, it kind of gets annoying to have to keep writing all these long names. All right, so now I'm also going to group, because I can't multiply all those numbers in the same step. So now I've also grouped the 5 and the 2 together, which will give me 10, and the 7 and the 4, which give me 28. And so that's the associative property. And again, you can abbreviate that too. Alrighty. And then we are going to actually, and I actually kind of missed a step right here that I wanted to show you. 5 times 2 times 7 times 4. This is actually the commutative part where I switched the order of the 5 and the 2. And then the fact that I put the parentheses around the 5 and the 2, that's the associative property there. And now I'm going to replace 5 times 2 with 10, because I know that 5 times 2 is the same thing as 10, and that's substitution. Substitution. It's important that you write out the substitution one, because you don't want to confuse that with subtraction. Like if you just put sub, we might think that you're saying subtraction and not substitution. So make sure that for substitution, you actually write it all out. And then the last thing is that we're going to replace the 10 and the 28 with 280. And again, that's also substitution because we know that 10 times 28 is the same thing as substitution. Sorry, why did I say that? We know that 10 times 28 is the same thing as 280. So we are replacing the 10 times 28 with 280. And that would be our last step there. So I apologize for forgetting that first step in there. But there you go. So now I will have you do it yourself example, where you will basically be doing the same thing but with different numbers. And once you have completed this example, then you will have completed the lesson for today. And we'll see you in class.